Welcome to my presentation. My name is Bo, and today I would like to present a dual-domain self-supervised transformer for accelerated multi-contrast MRI reconstruction. Multi-contrast MRI consists of multiple imaging protocols with different acquisition times in one exam, and the acquisition time can easily exceed 30 minutes depending on the specific protocol. Fast MRI, by reducing case-based sampling, is commonly applied to accelerate the protocol that requires long acquisition time. However, reducing the case-based sampling degrades the reconstruction quality with structural and non-local artifacts as shown here. There are many previous work on using deep learning for multi-contrast MRI acceleration. However, those works are typically supervised, requiring large-scale fully sampled data for training, which is hard to collect, and they usually use highly aliased zero-pad reconstruction as initial network input, which set a suboptimal initial point for network reconstruction. Moreover, they typically employ convolution architecture such as UNet as backbone network, which cannot model long-range and non-local contextual information for high-fidelity detail recovery. To this end, we propose a dual-domain self-supervised transformer to address these challenges. The reconstruction network input consists of a target domain, which is a slow MRI protocol that requires acceleration, and a reference domain, which is a fast MRI protocol that does not require acceleration. To enable high-quality initial input to the network, we propose to fill the unacquired case-based data into target contrast with reference contrast case-based data. An example of case-based filling is shown here, and the initial input of accelerated T2 image is significantly improved using this strategy. The proposed reconstruction network is a cascade network with backbone of Swin reconstruction network, which we will talk about in the next slide, and the typical data consistency layer, which keeps the already sampled case-based data. The backbone network consists of a series of Swin transformer blocks which build upon Swin transformer layer for efficient non-local contextual feature extraction for fine detail reconstruction. To enable self-supervised training without fully sampled data as training ground truth, during training, we randomly split the undersampled data into two partitions and have parallel reconstruction. If the reconstruction network can produce high-quality image, those reconstruction images should be consistent in the image domain, thus providing the image domain self-supervised loss. The case-based data of the image predicted from the first partition should be consistent with the other partition, vice versa, thus providing the case-based domain self-supervised loss. Visual comparison of our method and previous method is shown here. As we can see, our method on the last row not only outperforms previous self-supervised learning methods, but also previous supervised methods, generating reconstruction with the least residual error as compared to the ground truth. Our quantitative results also show that our method can generate superior reconstruction quality under different acceleration and protocol settings. Ablative study also show using dual-domain self-supervised learning is better than using case-based only or image domain only self-supervised learning strategies. Thank you for your attention. For any question, please send an email to this address and I will be happy to answer.